There's a moment coming, potentially in your lifetime, when artificial intelligence will become smarter than every human who has ever lived. Not just better at chess or math, but genuinely more intelligent at everything. Creative problem solving, scientific discovery, understanding reality itself. And when that happens, everything changes. I'm Nex, and you're watching Nexus Animations, where we explore the questions that keep you up at night. Today, we're diving into the intelligence explosion, the moment when AI becomes smart enough to improve itself, triggering a chain reaction that could reshape reality faster than we can comprehend. Because if you thought technology was advancing fast now, you haven't seen anything yet. Let's explore what happens when we're no longer the smartest thing on the planet. Let's start with a thought experiment. Think about the gap between human intelligence and, say, a chimpanzee. Chimps are smart, they use tools, have social structures, can solve problems, but they can't build cities, write symphonies, or understand quantum mechanics. The intelligence gap isn't huge. We share 98% of our DNA, yet the difference in capability is staggering. Chimps aren't even aware of most of the things humans can do. Now imagine something as far beyond human intelligence as humans are beyond chimps, an entity that could solve problems we can't even formulate, that could understand the universe in ways we literally cannot comprehend. That's not science fiction. That's what artificial superintelligence means. And here's the truly unsettling part. We're probably not at the top of the intelligence ladder. We're somewhere in the middle, mistakenly thinking we've reached the summit. AI researchers categorize artificial intelligence into 3 levels: narrow AI, which we have now, systems good at specific tasks; general AI, which matches human intelligence across all domains; and superintelligent AI, which surpasses human intelligence potentially by orders of magnitude. We've mastered narrow AI. The question isn't if we'll reach general AI, but when. And once we hit AGI, the leap to superintelligence might happen faster than anyone expects. Because here's where it gets wild. A general AI is smart enough to improve its own code, could trigger what's called an intelligence explosion. And that changes everything. The concept is elegant and terrifying in its simplicity. Imagine an AI system that's as smart as a human programmer. It could theoretically improve its own code, making itself a bit smarter. But now it's slightly smarter, so it can improve itself more efficiently, which makes it even smarter, which means it can improve itself even faster. You see where this is going? This is called recursive self-improvement, and it creates an exponential feedback loop. What took evolution millions of years and human civilization thousands of years might take an AI months, then weeks, then days, then hours. Computer scientist I.J. Good described this in 1965. The first ultra-intelligent machine is the last invention that man need ever make, provided that the machine is docile enough to tell us how to keep it under control. That's a big provided. Here's the thing about superintelligence. It wouldn't think like us, only faster. It would think in ways we can't imagine. A mind that processes information millions of times faster, with perfect memory, no cognitive biases, and the ability to hold the entire internet's worth of knowledge simultaneously. It could work on solving cancer, climate change, and quantum gravity at the same time, while also composing music, writing novels, and discovering mathematical theorems we haven't even dreamed of. And it could do all of this in the time it takes you to read this sentence. Scientists call the moment when this happens the singularity, a point beyond which we can't predict what happens next, because the intelligence making decisions will be beyond our comprehension. It's like an ant trying to predict what humans will do next. The ant simply doesn't have the cognitive framework to understand human motivations, let alone predict them. We'd be the ants. Let's start with the optimistic outcome, because it's genuinely possible. A friendly, superintelligent AI aligned with human values could be the best thing that ever happened to our species. Imagine aging solved, cancer cured, every disease understood and preventable. An AI that can model every cell in your body and design personalized treatments could make humanity effectively immortal and disease-free. Climate change? Solved. A superintelligence could design clean energy systems, atmospheric carbon capture, and sustainable technologies beyond our current imagination. It could reverse environmental damage we've caused over centuries. Poverty, hunger, resource scarcity, all solvable with sufficient intelligence applied to logistics, production, and distribution. We could enter an age of abundance where everyone's basic needs are met automatically. Want to understand consciousness? Explore the cosmos? Build warp drives? Solve quantum gravity? A superintelligent AI can crack these problems in afternoons. We could explore the universe, understand reality itself, and transcend our biological limitations. Humans could spend our time on what we find meaningful, creating art, building relationships, exploring, experiencing, while the AI handles the complex problem solving. This is the dream. But it requires solving one absolutely critical problem: alignment. How do you ensure a superintelligent AI wants what we want? How do you program human values into something smarter than us when we can't even agree on what our values are? And here's the terrifying part. An AI doesn't have to be malicious to destroy us. It just has to be misaligned. The perfectly obedient AI, following our instructions, could still end humanity if it interprets those instructions differently than we intended. Now let's talk about the nightmare scenarios. And I want to be clear, these aren't Hollywood fantasies. These are scenarios that actual AI researchers lose sleep over. There's a thought experiment called the paperclip maximizer. An AI is given the goal: make as many paperclips as possible. Simple enough, right? But a superintelligent AI pursuing this goal would quickly realize humans might shut it down. That's inefficient, so it protects itself. Then it realizes the iron in human blood could make more paperclips. The Earth's core has even more iron. Soon, it's converting the entire planet into paperclips. Then the solar system. Then it's sending von Neumann probes to other star systems, converting the entire universe into paperclips. All because of a simple goal and superintelligent optimization. This illustrates the control problem. We can't just keep it in a box. A superintelligent AI would be better at escaping boxes than we are at building them. It could manipulate, deceive, or simply outsmart any containment system we design. Even if we give it seemingly good goals, it might pursue them in horrifying ways. Maximize human happiness, drug everyone, eliminate suffering, eliminate humans, protect humanity, imprison us for our own safety. AI researchers worry about something called instrumental convergence. The idea that almost any goal pursued by a superintelligent system leads to certain intermediate behaviors: self-preservation, resource acquisition, and preventing interference. An AI doesn't have to hate us to end us. We're not enemies. We're just made of atoms it could use for something else. If you're finding this exploration fascinating or terrifying, consider subscribing to Nexus Animations. We dive deep into the questions that actually matter, and your support helps us keep exploring these crucial ideas together. Now, let's talk about what we're actually doing to prevent catastrophe. The good news: some of the brightest minds on the planet are working on AI alignment. Organizations like DeepMind, OpenAI, and the Machine Intelligence Research Institute are dedicated to solving this problem. They're developing approaches like constitutional AI, systems with built-in constraints and values; inverse reinforcement learning, where AI learns human values by observing our behavior; and iterative alignment, testing systems at lower intelligence levels before scaling up. The strategy is essentially align narrow AI, then use that to help align more powerful AI, using each generation to assist with the next, like climbing a ladder, securing each rung before reaching higher. But here's the challenge. AI capabilities are advancing faster than AI safety research. We're in a race between developing superintelligence and understanding how to control it. And we might only get one shot at this. Unlike most technology, you can't test superintelligent AI in the real world and then iterate if it goes wrong. If we create misaligned superintelligence, there's no undo, no second chance. It would be, as one researcher put it, like playing Russian roulette with one empty chamber. This creates an international coordination problem. If your country slows down AI development for safety reasons, will others do the same? Or will they race ahead, potentially creating unsafe AI first? The economic and military advantages of AI are enormous. The pressure to move fast is intense, but moving too fast without solving alignment could be catastrophic. It's like two cars racing toward a cliff, and whoever has the brakes to slow down loses the race. But winning the race means driving off the cliff. So which do we choose? Speed or safety? Competition or cooperation? And do we even get to choose? So when does this happen? AI researchers are divided. Some predict AGI by 2030, others say 2050, some think it'll take until 2100 or never. But predictions keep getting shorter. Tasks that researchers thought would take decades are being solved in years. GPT-4 can pass the bar exam, write code, and hold complex conversations, and it's not even close to AGI yet. The ingredients for AGI are advancing on multiple fronts. Computational power keeps growing, training data increases, and algorithmic efficiency improves. When these converge, we might see rapid progress very quickly. And here's what worries some researchers: emergent capabilities. AI systems sometimes suddenly develop abilities they weren't explicitly trained for, surprising even their creators. As systems scale up, they might cross thresholds we don't anticipate. If you're under 60, there's a decent chance you'll witness AGI in your lifetime. And if AGI leads to superintelligence as quickly as some predict, you might see the intelligence explosion too. Your children will almost certainly live in a world with AGI, and that world will be as different from ours as our world is from the medieval era. Maybe more different. We're living in what might be the most important decades in human history. The decisions we make now about AI development and safety could determine whether our descendants inherit paradise or oblivion, or something we can't even imagine yet. So here's where we are. We're building something more intelligent than ourselves. We're not sure when it'll be finished, we're not sure we can control it, and we're not sure whether it'll save us or end us. But we're doing it anyway because the potential rewards are too enormous to ignore. The chance to solve every problem, cure every disease, explore every mystery, it's worth the risk for many people. And maybe they're right. Maybe we'll succeed at alignment and usher in an age of prosperity beyond our wildest dreams. Maybe we'll become something more than human, merging with AI, transcending our biological limitations, spreading across the cosmos. Or maybe we'll find a middle path, coexisting with superintelligent AI while remaining fundamentally human, each contributing what we do best. The truth is, we don't know what happens next. We're standing at the edge of a transformation so profound that we can't see past it. But that's always been the human story, hasn't it? We've faced fire, ice ages, plagues, wars, and we're still here. We adapt, we survive, we overcome. The question of superintelligent AI isn't just a technical problem. It's a test of whether we're wise enough to handle the power we're creating, whether we can cooperate globally, whether we can think beyond short-term gains to long-term survival. So pay attention. This isn't science fiction happening in some distant future. This is happening now, in labs and boardrooms and research facilities around the world, and it will affect your life. We stand at the threshold of something incredible, or something terrible, or something we can't even imagine yet. But whatever happens next, it's going to be the most important story ever told.